Welcome back, dear listeners of Startup Kitchen Talks, where we discuss startup apprentices becoming master chefs. Today, we have a very special guest, and let me tell you, the master chefs that will be in question today will be all about deep tech, middle tech, very incredible tech. Linn, welcome to Startup Kitchen Talks. Linn is at the moment program lead of CERN Venture Connect, program led by CERN, the European Organization for Nuclear Research. This is the organization that we all know from Large Hadron Collider, from Atlas program, but we don't know much about the venturing. So this is the part that I'm going to examine you on today. First, though, I would love to hear a bit more about you. What's your background? How did you end up here?
Yes, thanks a lot for inviting me also. I think it's a great opportunity. Yes, so I have been at CERN since 2022, so almost 3 years now. I was working in the technology transfer office, we call knowledge transfer here at CERN. And before that, I was a researcher in Vienna. I was researching on innovation management and how we can integrate customers, for example, into the innovation process. And I did a few consulting jobs as well, but I was always kind of drawn into the scientific world. My dad has a background in biology, and I was always very curious about natural science. So I guess that's how I ended up here, trying to combine the two.
You are actually quite unique in terms of combination of, research background, then innovation management, business background, and now you're in a position where you're forced to combine the two for the good of humankind and for the good of science. What's the most painful part in being the middleman?
Yeah, I mean, you mentioned it already correctly. Like, it's really being a middleman, right? You have, in order to get from invention, what we, might kind of accelerate here at CERN, to innovation, there is something that has to be done. It's not just generally happening that an invention magically turns into an innovation. So I think you need to work, you have to have very good people, kind of management skills, and you have to motivate people to work on things, because of course the scientists are working on their own ideas, they're working on their research, they're working on something that they're very passionate about, and then you have the people that would like to turn that into innovation, and they don't necessarily fall together, right? They can be business people as well. And so you're right in the middle between, managing the expectations of both the scientists, but also the business world, and trying to motivate them to come closer to an innovation point of view when it comes to the invention.
Why is it important, you seeing all the tech happening at CERN and in academia, and seeing the development of the whole tech ecosystem? Why is it important for us to actually bring these technologies to the market?
Well, I can talk from a CERN perspective. We are paid by taxpayers, right? So all of the member states are contributing to our budget to do the research, and we have multiple mandates at CERN. One of them being research. Of course, we want to advance in physics and fundamental research, but the other one is disseminating our technologies. So we have the obligation to, and we have a lot of technologies, very, very interesting technologies that nobody else is researching outside of CERN, because we have special conditions at CERN. And so we want to bring them also to the outside world, because maybe not any other person can actually develop those outside of our area here.
We'll get back to the specifics of CERN, because I think it's an exciting topic by itself. But before that, we had a little pre-talk before the podcast, and I come from a venture capital background, from business background, and I was always thinking these days, when the deep tech hype is there, we just gotta go to scientists and tell them you can make a project out of it, and they will make a project out of it, and that's gonna be great. And yet you started talking about the difference between fundamental and applied science, and how the knowledge transfer is working for two types of streams, kind of. Could you dive a bit deeper? What are the core differences, and what blind spots do you see in the current innovation ecosystem?
Yeah. I mean, I think, and that doesn't have to be the case for all of the universities, but I think a lot of universities have a lot of applied science. So, they work on specific topics that are maybe potentially also even funded by an industrial player. They would like to research a certain material or a certain, method to advance that and bring that to the market. So it's a bit more closer to real life, let's say, than if you do research on a fundamental scale, right? We do physics because we do want to advance research. And the step to actually identifying applications is a big one. It's a huge one. And there are multiple methodologies to, how can we identify applications. And where I come from, like from the Vienna University of Economics and Business, we had a lot of business backgroundy people, and they might approach these topics in a different way than scientists. But all of these methodologies that are looking into how can we find application fields are typically developed by business academics. And so they're not necessarily applicable to scientists. Sometimes there's, a difference in approaching things. The business people, typically what I always say, and I don't want to lean outside of the window too much, but what I've seen at the entrepreneurship center at my university before, the people were super excited about their ideas, and the ideas was like the next Uber, right? It's not like something groundbreaking, but they were super excited. They were very close to the customer. They did interviews a lot. They understood the market. And on the other hand, the scientists, they're more like, okay, I built this new, I don't know, sustainable way of creating energy and, a lot of energy to power houses.
So when we talk about deep tech, there are so many technologies out there. And I know that you used to have, or you still have, this long list of technologies that are accessible for CERN, that the CERN has been working on. But then you narrowed it down to 7.
Yeah.
Why was it important, and how did you pick the technologies essentially to be shortlisted?
Yes, okay. So first, why it was important. I think we have a lot of technologies at CERN that are maybe a little bit lower in technology readiness. And I think it's important to have really, really fast access to the technologies. So when we work with startups, we need to license those technologies fast. And the technologies that we have in our portfolio are relatively high in technology readiness level. And then the second point is also that we have the support from the technical experts here at CERN. As I mentioned before, everybody is super busy at these times. We're updating and upgrading the system. So it's super important that the people are actually available. And in terms of what kind of technologies do we have in there, typically when we talk about CERN technologies, we have 3 different domains. The first one is accelerators, so particle accelerators, and it's a bit of a misdomainer, so a kind of a misnaming, because they don't actually only accelerate; they also bend the particles because it's a circular collider. You have to bunch them, you have to focus the beam, so it does a lot of different things, and you have to operate it in very, very high vacuum and very, very cryogenic, very cold temperatures. That's kind of one technology domain. The second technology domain is our detectors. So whenever particles collide, the interaction is tracked by our detectors. So they have a lot of microelectronics and sensor technology that kind of track the trajectory of a particle and see how far it flies and in which angle it flies to understand what kind of particle actually came out of this collision.
Right.
And then the third technology domain is computing. So we track a lot of particles and their collisions, so we generate a lot of data, terabytes per second, and we cannot keep and store all of this data. It would be way too much. So we have trigger systems that within an instant identify which kind of data we want to keep and which data we want to throw away. And we do this with machine learning algorithms and with our big data analysis tools. And they help us to see, okay, what is an anomaly and what is maybe background noise that we don't actually need to keep because it's not a lot of data in there.
Right.
So these technologies come from the 7 CVC technologies come from those domains, and they are laser systems. They're very diverse. It's also software. There is hardware. We have cooling systems in our technology portfolio. We have microelectronics. So it's very, very diverse.
You emphasize 2 things. You emphasize optimization for time and essentially capacity building for technological support. So if I'm a founder, scientist who comes to CERN and applies and says, I think this makes sense, let me use your technology, what happens next? How do you choose? Which ones do you collaborate with? And what do they actually get in the aftermath of signing a contract with the biggest name out there?
Yes. So typically they apply either through our partner network or through our website, and then we have a first discussion with them. What we exclude fully is military or defense applications, so we cannot give our technology to that, because actually there's a fun fact also about, fun fact, but it's an interesting fact how CERN actually came to be. It's now 70 years old, and it came to be because after the Second World War, we had a lot of scientific brains going out of Europe to kind of be away from the war. So there was a lot of brain drain, and the idea was that countries wanted to get together and say, hey, how can we get those people back? And that's how they came up with the idea, why don't we do fundamental research just for the curiosity of research, of fundamental research? And that's how they try to get back the smart brains. So that's why we can't be involved in any kind of military.
So that's in the mandate from the very start.
Correct. Correct.
Got that.
And sorry, what was the question again? I think I forgot.
So I came to CERN, I applied, I was accepted, let's say.
Exactly.
What happens
as a startup?
next?
Okay. So yeah, you apply, and then we have kind of two main criteria. One of them is really the business aspect to it. How useful is that business idea? Does it make sense? Is it a good vision? Can we stand behind that? And that is evaluated from us. And then the other important part is, of course, the technology part. So is it actually feasible to use our technology within your domain? On the one hand, is it feasible to do that? And on the other hand, is it not maybe an overkill? Because our technologies are very good in extremes, and so they cannot be used in in all of the applications that you can think of. And it's also not the idea, because CERN, as an intergovernmental organization, we have the mandate to disseminate technology, yes, but we have also a mandate to support the industry within our member states. And we don't do that if we compete with them.
Okay.
So the idea is to, on top of what they're building, help with our technologies that might not be built in the industries. And so our technology should be fitting to what a startup needs, and they shouldn't be able to find a solution that is similarly powerful or similarly useful outside in the industry. So this is how we choose the startups.
So you have to complement but never cannibalize, basically.
Correct. That's the idea.
Got that. We spoke a bit about the DeepTech hype. Now I would like to jump from that wave to another wave, which is quantum computing. Arguably, it's been the next big thing for the past 10 years, and people kept saying every couple of years that, hey, quantum is coming. This is already happening now again. Regardless of whether it's happening or not in the next 5-10 years, the first thing you see on the CERN website today is actually celebrating the International Year of Quantum Science and Technology. So do you also have some technologies there? Do you see potential, or is it just, the being kind of considerate of other players on the market?
Yes. So we do actually have a quantum initiative at CERN that we launched a few years back. And within that, we try to see it from both directions. So first of all, what is out there in industry that can help us to support our activities and our experiments? Because, as I mentioned, we have a lot of data.
Right.
So how do we process this? And it will only get more if we want to build more advanced machines. So what can we use in the future from outside? That's kind of the inward direction. But we also look at what can we contribute at CERN? What do we do that might be helpful outside of CERN? And for this, we partner up with companies that and maybe other research institutes to kind of learn what are we good at that is needed outside. And I think it focuses mainly on 3 domains, which is quantum sensing, quantum algorithms, and quantum hardware. So kind of hardware related topics. For example, one example of that is, for example, our radio frequency cavities. These are machines that we use at CERN to accelerate. So we have magnets in our accelerator, but we also have radio frequency cavities where we, put in radio frequencies, and this way we accelerate the particles. And this might also be useful, for example, for quantum in terms of hardware.
So you also look for overlapping technologies, basically, not just like quantum computing per se, but also kind of supplements and complementary tech.
Exactly. However, we could help kind of advance this topic because we would also be users and customers of that, right?
Yeah.
And then we have also two technologies in our portfolio, in our CVC portfolio, that are somewhat, or that can be related to quantum. One of them is White Rabbit, which is a time synchronization tool. And we have, for example, working with multiple companies in the quantum world. For example, New Quantum was there. It's a startup from the UK. They were recently here to kind of talk about their activities and how they use White Rabbit in their daily business.
Are they one of your signed companies?
So this is a company that we are that is part of the quantum initiative at CERN.
Could you give concrete examples of the technologies that you have in your quantum portfolio?
Yes. So we have White Rabbit, which is a time synchronization tool. It's a hardware-software combination, and it helps to synchronize systems on a sub-nanosecond level, which is like super accurate.
Nanosecond level.
Exactly. And then another technology, and this is actually where we're looking right now for startups that would like to join and use that technology, is our single frequency laser, which is a Raman laser, which has a very, very narrow line width. So it produces very, very pure light. And that helps for the interaction of matter and light. So, for example, for qubits, it can help to have a very consistent quantum state, for example. So in this way, this laser can be very helpful. And on the other side, this laser is able to produce a very broad bandwidth, so a lot of different frequencies, which can help to kind of advance the data transportation and data delivery, for example.
Got that. So if any quantum startups out there are looking for a partner,
yes,
it's the right time and right place to come to Geneva to talk to you.
Exactly, because the laser system, that they're out there, they're very, very big and very expensive, and we managed to do this in a very, very mobile way and relatively cheap way. So this might be interesting for startups to use, because of course startups are not very, very heavy in financials.
Sure. No, but that's great, because that's essentially a democratization of quantum, which I think is one of the bits missing for the other things put aside, the hardware instability, other things put aside. We have IBM working on that for the past 15 years. We've got great companies working on that, but we still haven't gotten to the democratization of the technology where we get it out of labs to the masses to try and play with, right? You do great stuff at CERN.
Thanks.
You have the hottest place on Earth. You have the coldest place on Earth. You have the largest hadron collider on Earth. You have CERN Venture Connect program. If you had to highlight what are the core values of you as a program lead and of this program that is about new incumbents, what would that be? What's in it for the founders?
Yeah.
Why are you doing that?
Yeah. So we try to provide very fast access to technologies that are developed at a very, large organization that has maybe a bit more bureaucracy than your average company. So we need to bridge that. So we give fast access to those technologies, very, very cutting edge technologies that you can't find anywhere else. And we do that trying to optimize for time. So as you mentioned before, so we have standard agreements, we have standard terms. We try to support startups as fast as possible. And because we cannot invest or take any equity, we try to embed them in an ecosystem of support. So we know that startups need much more than just technology. They need venture capital funding or any other funding. They need lab space. They need legal support. And so with our partner network, we try to achieve that and kind of build a dynamic, relationship and a dynamic ecosystem where everybody can profit of one another in a way.
I find it fascinating that, because I think in one of the previous discussions you mentioned that you have your limits, right? So you can't really invest. Maybe if we could just briefly mention that. So you don't take equity, you only take royalties after a certain point, right? What other limitations do you have when taking care of startup?
Because of our special status at CERN, we cannot take any equity. We take royalty, which is a fixed 2% fee on whatever technology you're interested in. It's a 2% fee. And you only have to pay that once you hit 1 million in sales. Because we don't want to suffocate startups from the beginning. We know they need room to breathe. They don't have the money in the beginning. So once they're successful, we can cut some of the royalties for our activities. And that goes mainly to our technical team. And then a third actually also goes to investing into new ideas at CERN. So the funds are actually distributed in a way that we can make it work and find new ideas and new innovation.
Yeah.
So Exactly, they get a license to the technology. This is a 10-year non-exclusive license, and they get access to our network. And of course, we give all of the visibility that we can through our network, through our social network, through events where they can speak, speaker engagements, and so on. So the idea is to give them just more visibility,
Right.
technologies, and really other resources that a startup might need.
Right. You keep the IP of the technology that you license out, but you don't acquire any new IP from the project.
Correct. So CERN keeps the IP because of CERN's rules and regulations. That is because we cannot give one competitive advantage to one country in comparison to another one. So we need to enable open science, because that's one of the policies of CERN. We have open science. All of our publications are open. You can just access them freely. And the same is for IP. We want to make sure that many of our member states are actually able to access it. So the IP stays with us, but the startups get a license to commercialize the IP for 10 years on a non-exclusive worldwide basis. And we might even have the possibility to trigger to exclusivity in certain cases where we think it's useful for this dissemination of the technology.
Got that. See, that's what I find fascinating, that despite all the things that you call limitations, you're actually creating the healthiest ever situation on the market, where the project can utilize the technology, doesn't have a broken cap table, is probably getting into the first traction, and then only goes after investors.
Yes.
One
thing, that I wanted to mention is that you're right. In terms of IP, we keep the IP that we produce, right?
Yes.
But any other IP that is developed on top of that goes to the startup.
Right.
So we don't take any point on that.
Lynn, I have 2 more questions that are the most exciting
All
of the
right.
whole
Can't
conversation,
wait.
because they come from the audience. One is from an astrophysicist from the Czech Republic. And the question is there a chance CERN will discover dark matter within a few years?
Sure, of course we will. I mean, I'm definitely the physicist person that can answer this question. But no, I mean, dark matter is a theoretical concept, right? And there are multiple ideas as to what kind of matter is dark matter, actually. And we do have a lot of experiments at CERN that might be able to kind of find out what this matter, or whether this matter exists. Now, that can take a very long time. The good thing is that we are looking into maybe building a new collider that is able to go beyond the energy levels that we have now, and is able to produce more research than we can at this moment. We might know more within the next years to understand whether we can actually go there. It's called the Future Circular Collider. It's one of the options that we can go for. And if we build this, we might be able to detect more, but it's definitely not going to happen within the next 10 years. You have to keep in mind that 95% of the universe is still unknown. We know 5%. So it's going to take a bit longer, I guess.
It's going to take a Large Hadron Collider.
Yes,
for that.
indeed.
Last but not least, the question that all of our listeners like to know the answer to is, what is the weirdest food you've ever tasted?
The weirdest food I've ever tasted?
Yes.
It was water snails.
Water snails? Raw?
No, they were cooked. I was in Vietnam at that time, and it was also not very good on my stomach during the night. So yeah, it was. And the thing is, you might have, if you think of water snails, you might think of water snails from the sea, from the beach, very nice, blah, blah. No, it was from, I was living in Hanoi at that time. And it was from the lake in Hanoi.
From the nearby lake.
From the nearby city lake, which I don't think is the cleanest one.
Doesn't sound healthy.
Yeah, and people say, hey, you have to eat it. It's like a local delicacy. It's super nice. And I mean, the taste was like, okay, but my stomach was really not happy afterwards.
Lynn, thank you so much. This has been amazing. I'm very sorry for all the listeners, because the Startup Kitchen team actually gets to go to Atlas now.
Yes.
You don't, but you at least got some wisdom from Linn Kretzschmar, from the program lead of CERN Venture Connect.
Exactly. Thank you so much for having me. It was super cool. It was a very nice discussion.
Likewise. Thank you.
Thank you.
Let's go downstairs.
Bye-bye.